Hello everyone, my name is Charles Marak from Assam Don Bosco University, Department of Physics. The topic which I am going to present is from class 12 and the topic current electricity. Based on this, I have chosen Kirchhoff's laws. So we know that Kirchhoff has given two laws to solve complex circuits, namely Kirchhoff's current law, that is KCL, and Kirchhoff's voltage law, that is KVL. So now let's come to the first law, which is the Kirchhoff's current law, or the KCL. The algebraic sum of the currents entering and leaving a node is equal to 0, which is given by summation of I equal to 0. Here you can see there are different amperes of current entering and leaving a junction. So the sum of the currents entering and leaving a junction must be equal to 0. And the next point is currents entering a junction are positive and those leaving a junction are negative. And this is given by summation n equal to 1 to n of In is equal to I1 plus minus I2 plus minus I3 plus minus I4 plus I5 equal to 0. And this minus sign indicates a current leaving a junction. For example, suppose for a number of friends entering the path from a fixed point, and that we assume the path leads to same point and no extra path exists. Therefore, the number of friends entering the path should be equal to number of friends exiting. Similarly, for this current, if I1 and I2 is the current flowing in and I3, I4, I5 is the current flowing out, then we can have I1 plus I2 is equal to I3 plus I4 plus I5, which is expressed as summation I equal to 0. Why? Because all incoming current is equal to all outgoing current. Hence, Kirchhoff's current law, or the KCL, states that the algebraic sum of currents meeting at a point is 0, given by summation I equal to 0. Here a brief explanation on KCL. Suppose some conductors are meeting at a point A, as shown in figure. In some conductors, currents are incoming to the point A, while in other conductors, currents are leaving or outgoing from point A. Now let us consider the incoming or entering currents are positive towards point A, while the leaving or outgoing currents from point A is negative. Then we can express this as I1 plus minus I2 plus minus I3 plus minus I4 plus I5 is equal to 0. And it can also be written as I1 plus I5 is equal to I2 plus I3 plus I4 is equal to 0. That is, incoming or entering currents is equal to leaving or outgoing currents. And we can conclude that summation of I, which is the current entering, is equal to summation of I, which is the current leaving a junction. Next, we have Kirchhoff's voltage law, or the KVL. Kirchhoff's voltage law states that in any closed path for the circuit in a network, the algebraic sum of the IR product is equal to the EMF in that path. Here I is nothing but the current and R is the resistance. In other words, in any closed loop, which is also known as mesh, the algebraic sum of the EMF applied is equal to the algebraic sum of the voltage drops in the elements. Kirchhoff's voltage law is also known as voltage law or mesh law, which is expressed as summation of IR is equal to summation of E. A brief explanation on KVL. A closed circuit is shown in figure which contains only two connections of batteries E1 and E2. The overall sum of EMFs of the batteries indicated by E1 minus E2. The imaginary direction of current is also shown in the figure. E1 drives the current in such a direction which is supposed to be positive, while E2 interferes in the direction of current. That is, it is in the opposite direction of the supposed direction of current. Hence, it is taken as negative. The voltage drop in this closed circuit depends on the product of voltage and current. The voltage drop occurs in the supposed direction of current, which is known as the positive voltage drop, while the other one is called the negative voltage drop. If we go around the closed circuit or each mesh and multiply the resistance of the conductor and the flowing current in it, then we can sum of the IR, which is equal to the sum of the applied EMF sources connected to the circuit. The overall equation for the circuit is expressed as E1 minus E2 is equal to I1 R1 plus I2 R2 minus I3 R3 minus I4 R4. And if we go in the supposed direction of the current as shown in the figure, then the product of the IR is taken as positive, otherwise it is negative.